And tell your friends, just we are waiting for 2 minutes for others to join. I think we can start. Welcome all to the 5th session of this workshop. First, in the first part, we will discuss, not this, yeah. We will discuss p-value, power, and sample size, the concepts we discussed last sessions, just a quick revision. After that, we will go to an overview of statistical tests, but we will go in more details and in more practical tips in the coming sessions. This is for the first part, and for the second part, we will discuss how to deal with data, collecting data and dealing with them, and with questionnaires. And the third call can be for your questions. Please don't forget to fill in the attendance sheet. So, if we are ready, we can start. Please just tell me if you are ready, or just please put thumbs or anything. Okay. For the revision, if you remember, we had the null hypothesis and the alternative hypothesis, and we have our decisions and we have the reality. Okay, sometimes we, or actually most of the times, we get good conclusions. We accept the null hypothesis while it is true, or reject it while it is false. But sometimes we have these errors, type 1 error, when we accept the difference and the alternative hypothesis while actually the null hypothesis is true, or type 2 error when we accept the null hypothesis or actually we do not reject the null hypothesis while it is actually rejectable. And here we can see them again in from different perspective in continuous data. So what is p-value? P-value is the probability that type 1 error will happen. So we assume that the null hypothesis is true, and we assess that probability while we are accepting the alternative hypothesis, but actually the null hypothesis is true. We need the p-value to be smaller than 0.05, okay? And anything higher than that will be included in our null hypothesis. So we usually aim for that at least 0.05, sometimes even smaller. We remember that all our discussions were about type 1 error, but we had a complaint from type 2 error, and we need to discuss what does type 2 error means. And we discussed that type 2 error means power, okay? Actually, it completes power. So we have here type 2 error, which is beta, and power is 1 minus beta. So beta in itself is not that important, but we usually talk about power. So what is the importance of power? If you remember, more sample size means more power. So we need that to predict the sample size we need, okay? So what is power? Power is actually the probability of detecting a difference. Remember, the alternative hypothesis is here and power is here. So we are detecting the difference when there is actually a difference, okay? Not beta, but here. There is a difference and we are detecting it. So more power means we need more sample size. Okay, what other contributors to sample size can be? We talked about this. If we need more power, if I need a 90% power, I need more sample size than an 80% power. If you remember, we talked that if we want two-sided tests, we will need more sample size because power will be lower, okay? Actually, these factors affect each other. So when they affect each other, they also affect the sample size. Standard deviation, when we have a higher standard deviation, means we have more variability. And when we have more variability, we need higher sample size. The difference between two groups, we have this distribution here and this distribution here. And when the difference is small and the groups are close to each other, we need higher sample size. When these groups are really far away from each other, we do not need that that many participants. The significance level, if you remember, the significance level was the alpha error. And if you remember those errors, when these errors are less, we do not need more sample size. But when we have those higher, we need more sample size. So if we have less sample size, what will happen? If I have a small sample size, I will have a higher standard deviation. I will have more variability. I cannot get a p-value of 0.05. And my conclusion, I can't drop conclusions, but these conclusions mean nothing statistically. Okay, so what we need to do is to go to the calculator, put the numbers we need in this calculator. If you remember the significance level, the alpha error, the difference between groups, for example, I can put that the difference I expect between those two groups is 20% or 50%, and that will affect our sample size. And all the other factors like the confidence interval and the power I need, and I will get that number. And when I get a number, for example, I got, for example, a 12.5. I shouldn't put 12 patients in my study. I should put 13, okay? Because when I reduce the number, I have that probability of getting lower difference between the groups. And if the difference was just lower by 0.1, that will affect my p-value. And if the p-value just crosses the line from significance to not significance, then my study will go unpublished. Okay, Actually, we are talking in the best way. If we calculate the sample size, and the sample size means that we need, for example, 500 rheumatoid arthritis patients, and actually my country or my institution doesn't allow me to get that sample size. So this is actually not the ideal situation. We usually aim for that, and we calculate and we do our best to get the best out of the study, but sometimes it's not like this. Sometimes I have those assumptions. For example, I assume that people with some kind of cancer will be higher in their age, will be older than the normal population, okay? And I expect them to be like higher in 10 years than the normal population in their means. So sometimes I assume that to calculate my sample size, but suddenly they're just higher by 9 years in my country, not 10 years. That can be affected by the sample size, by the sampling, by everything. So 9 from 10 to 9 will change my sample size, the required sample size. Then I will get a p-value that is not significant, but I actually calculated the significant number. So assumptions can, those violated assumptions can make it difficult. And of course, the limited sample size can make it also difficult. So are we okay with that? So we can move on to the statistical tests.
Ibrahim, I have a question.
Yes, please, Lina.
Regarding the sample size, sometimes it also depends on the disease itself. So that's why you told us it depends on the prevalence. So if the disease is rare, the sample size and it will be lower than other studies. So when I calculated, they will take this into account, right?
Yes, but actually not for every study. We need to put the calculator for the study I want to do. Okay, for example, if I'm searching for a percentage, just a normal percentage for rheumatoid arthritis patients who, for example, die in 10 years or so, the calculator will tell me what I need to put in to give me the sample size. Yeah, for some studies, it will require the prevalence of that disease. Sometimes it will ask me what is actually the total population of patients in that. It depends on the study I want to do, and it depends actually on the statistical test. For example, if I have a study that, we will talk about that, but for no study, I will have just one outcome, okay? Usually I have several outcomes and I compare them. So if I take the first outcome, it is a continuous outcome, age, for example. If I calculate my sample size according to it, the sample size will be different from the second outcome, okay? And here comes the principle of primary outcomes and secondary outcomes. Actually, on the most important outcome, okay, and I calculate my sample size according to it. And it is better to calculate the sample size for several outcomes and take the biggest sample size out of them, okay?
Okay.
Mm-hmm. Any other question? Okay. For the statistical tests, actually, what I included here are a number of pictures I took from the internet. You can see that they all discuss the same criteria, and we will see that actually in different books you will find different rules how to decide on the statistical test you want to do. And of course we have those very complex statistical tests, and nobody can do them unless is an experienced statistician. So we will just learn about those basic ones and how to decide which one should I take? Okay, and of course, we're not learning them just to do them. Sometimes we need to learn them to understand if this study is doing a good job in its statistics or not. Okay, first we need to know several characteristics about my data. The first thing is, are my data categorical or continuous data? Okay, so first, if I have categorical data, we remember that we have either the 2x2 table or a percentage. So if it is a one sample, I have one sample proportion. If I have two samples or two samples special, it means like the two samples are paired. Each one of this sample relates to one in that sample, like case control studies. Actually, in case control studies, I do not compare just the whole group to the whole group, but I usually have a control for each case, okay? A matched control that has the same risk factors and everything that is similar. So for two samples, I have two sample proportion, and for those, we usually use chi-square test. Okay, what about quantitative data? If I have one sample, what is the test I usually do? I compare the mean and the standard deviation of this sample to the normal distribution of the population in my country, for example. Okay, or if they are athletes, to the whole population of athletes, and so on. If I have two samples, I need to compare those two samples to each other. Those two samples can be like cases and controls. Those can be exposed and not exposed, and so on. Two samples is special. What can they be? For example, they can be a group that is treated and the same group before treatment, okay? Or a group and the same group after a while, or a group and a matched other group. So for those, I use the two sample T-Beard test. So they are both, actually the three of them are t-test, but here for the one sample t-test, he will ask me for the mean and the standard deviation of the normal distribution of the normal population. In the two sample t-test, he won't ask me, he will tell me, give me the numbers for the first arm and the numbers for the second arm, and I will calculate the p-value. For two sample paired t-test, he will tell me like put the patient with each other, each patient with each control, and I will calculate the t-test. They will differ from each other. If I have more samples than two, okay? If I have more than two arms, for some studies we have two controls for each case. In some studies, we have treated, non-treated, and treated after 10 years, for example. Sometimes we have different dosage for my intervention. So I have three groups, okay? For those, I can't use t-test. Remember that t-test is just used for two samples. For three or more, we need to use a test that is called ANOVA test, okay? For the two samples, if I don't just want to put a relationship, remember that a t will give me a p-value and will tell me those two groups are different from each other, or they are exactly the same, okay? It will give me that probability. But if I want to say if the age get longer, mortality will get higher, okay? So in this, I do not need just age and mortality affect each other. I need, does age affect mortality when it is when it gets longer, mortality gets higher? So the answer comes from correlation or regression. Okay, if we understand these rules, we will apply them to all the other algorithms. Okay, and I really hope that you interrupt me, ask questions, or even try to draw conclusions from those slides yourselves. Okay, first we have dependent and independent variable. And what is the difference between them? The independent variable is usually age, something that is not affected by anything. Okay, the dependent, for example, mortality, the disease, or for example, we have the independent as the disease and the dependent mortality, or something that is affected by the disease. Okay, so if I have a nominal and an interval, okay, so remember, a nominal will give me 2 categories, 3 categories, and so on. Here they are saying we have a nominal. I want to ask, do you see my pointer?
Yes.
Ah, perfect. So what will this variable make? It will divide my population into 2 groups. Okay, and my dependent variable is interval, so it is continuous. Okay, so I have 2 groups, each one of them has continuous data. So the test is t-test. I think you all agree. Okay, if I have nominal 3 or more categories, okay, so I have 3, 4 groups, okay, let's say 4 groups, and the dependent variable is interval, okay, so for each one of them I have continuous data. What is the test I'm going to do according to the last slide? It's an ANOVA test. Exactly. If I have interval and interval, okay, if you remember, if both variables are interval, this is continuous and this is continuous, I have 2 options, either to cut one of them into half. Okay, so I have 2 halves now. Some of them are higher and some of them are lower. So I converted one of the interval variables into a dichotomous variable, okay, or a categorical variable. So I will have the ability of do a t-test, but what is actually harder, but it will give me a more important conclusion, is keeping them both continuous and do a correlation or regression. Exactly, Sara. So, and the last one, if I have nominal and nominal, which is the easiest, we do chi-square. And for the chi-square, it doesn't require to be just 2, okay? When I have 2 and 2, okay, no, I'm not clear. If I have a variable that has 2 options and another variable that has 2 options, and I have a 2 by 2 table, I can do a chi-square and I can do other tests. But when I have a 2 options for the first variable and 3 or 4 options for the second variable, I have to do chi-square, okay? So chi-square is the normal standard, but when I have a 2 by 2, the smallest possible 2 by 2 table, I can do other tests, for example, Fisher exact tests. Okay, we will go to another algorithm and we will, actually I put a lot of algorithms just to remember, okay? There is no so important logic in that. Those are names for tests, and those tests, we do not need to understand how they actually work. We need to know where to apply them, and when we apply them, we need to know what are the numbers that result, okay, and where to put them. So now we will just learn where should I use each one of these tests, okay? Here we are testing means. Then I understand that here we have continuous data, okay? If we have more than 2 samples, I think all of you agree that we should use ANOVA. If I have a one sample, here we have an additional classification, okay? We can use t-test, but it's better when the sample size is lower than 30, we use a t-test, but when it is higher than 30, we should use a z-test, okay? And remember that t-test is named one sample t-test. Why? Because we need to provide our, or not our, but actually the normal mean and the normal standard deviation or confidence interval or whatever. Okay, if I have two samples, the same rule applies here. More than 30, we have the z-test. Less than 30, here we have another criteria to classify them. Okay, when I apply the test asks me, is the variance between the two groups equal? Or it doesn't ask me if the variance is equal. It asks me, do you expect the variance to be equal? So, for example, if I'm taking a sample of SLE patients and a sample of the normal population and I'm calculating ages, do I expect the variance to be different from these two groups? Okay. I can do a test, I can go back to the already published data and I can expect what the variance of my samples will be. Okay, so when it is assumed equal, we use the bool t-test, and assumed unequal, non-bool t-test. Okay, those names shouldn't be like exactly remembered, but when they ask, we should know that if they ask me, not they, actually SPSS or Minitab, the program of statistical analysis, sometimes it asks me, do you expect equal variance or not equal variance? And according to what I put, it will give me a result. Or sometimes they do not ask me, but when they give me, sorry, the table of results of that chi-square, or not chi-square, sorry, the t-test, they will put a column for assumed equal variance and a column for assumed unequal variance. Okay, it can be both ways. Here we are again. Yes, please.
Ibrahim, can you go back to the slide, previous slide?
This one?
Yes, when the number 30 is for each sample, right? So if I have two samples, yeah. So I also have another question. If my sample is the same, yani, the same sample, I did an intervention and I compare it with the result, I consider it two samples also, right?
You are comparing those people to themselves before the intervention.
Yeah.
Yes, two samples, two samples paired two samples.
Ah, okay.
Okay. Yes. Actually, the sample means that I collected data. So if I collect data now and I collect data after something, then those are two samples. Okay. Here we will go again to categorical and continuous. They ask me here categorical. Okay. Yes, please.
What was Z-test and T-test names in Arabic?
Come on, T-test.
Yeah, T and Z test, same name. Yeah.
I don't think they are different.
Yeah, I don't remember them. That's why I asked.
Yeah. I don't think they discuss them in so much details in our universities. Yeah. Okay. And actually, programs do them exchangeably, so don't worry about them. And don't worry about Arabic in research. Okay. For categorical data, we need to compare proportions. Okay. And if you remember, proportions means that we have 2 by 2 table a cell on a cell gives me one proportion, and the cell on a cell gives me another proportion. So when I'm saying comparing proportions, it's equal to saying that I'm comparing a 2 by 2 table, okay? Because a 2 by 2 table gives me two proportions, and this is done by a Fisher exact test or a chi-square. Here we go back to continuous data. For continuous data, how many groups? 2 groups. Here we have another classification: normal data and non-normal data. Okay, that question is really important for statistical analysis. We need to understand if my population or my sample gives me normal distribution or not a normal distribution. Okay, because if it is not normal, I need to transform it to make it normal, to use the usual tests, the t-test, the ANOVA test. I need a barometric. A barometric means normal. So barometric normal, those are the samples I can work with, but there are actually tests for non-barometric or non-normal samples. Okay, for the non-normal we use Mann-Whitney. Okay, and this is the first time you see that test. But for the normal, I think you remember it, we use the t-test. Okay, for more than 2 groups, normal
What
data.
do you mean by normal data?
Normal distribution, a data that give me a normal distribution when I put them in a histogram.
Or normal samples, I mean.
Okay. Yeah, and non-normal data, we use this Kruskal-Wallis test. So those 2 tests were not presented before, and they are difficult, and I don't know if we'll have the time to do them, but we need to understand that ANOVA and t-test are the tests we should understand and we should learn about. Okay, here there is another algorithm. Is data distributed normally? And this question comes here from the very first. Okay, no and yes. We should start with the yes if there are 2 groups or less. Okay, if there are 2 groups, then if there are more than 30 z-test, less than 30 t-test. Okay, but no, which means I have 3 groups or more. Okay, remember that a t-test can apply to 1 sample or 2 samples, but if we have more than 2, we will need to use ANOVA, but the data should be normal. Okay, is the data normally distributed? No. Okay, when it says no, then I need to understand, I need to remember that is it categorical or not categorical? If it is categorical, okay, we need chi-square test. Okay, you remember that, I think. And if it is not categorical, we need to go to Mann-Whitney. Mann-Whitney, you remember it here, from non-normal data, continuous data, 2 groups. Okay. Here, another one. We have input variable, output variable. It means independent and dependent variable. Numeric, sorry, let's start here. Categorical, chi-squared. Categorical, nominal, or categorical, numerical, and numerical, categorical. They should give me the same outcome, okay? Because one categorical and one nominal means according to one I will split the group, and according to other I will give numbers to them, okay? And both I can use the ANOVA test, okay? Don't think about the other tests. When I have numerical and numerical, if you remember, regression or correlation, and those are the names of the tests, Spearman and Pearson. I will skip just one. Here, we will just remember them for the last time. Type of data, categorical, chi-square. One sample, two sample, whatever. Okay, if there's one sample, I compare it to the proportion of a normal population. Continuous data. If I need to do differences or I need to do relationships. Remember, if I want to do that relationship, when something goes up, the other thing goes up, then we need regression or correlation. Okay, well, when do I need regression and correlation? It depends on if they are dependent on each other, or one depends on the other, or they are independent, but I'm putting them on a scale. Okay, we shouldn't go in more details in that, and you remember that correlation means person or spearman tests, non-parametric, parametric. Okay, don't think a lot about the names because we will revise them or we are going to do them, and we are just left with this arm. For this arm, we have continuous data. Okay, continuous data, and I just need to do the differences. Okay, when I have that, if it is a single mean, one sample t-test. Okay, if it is multiple means, okay, just skip this. Don't think about the variances. When I have multiple means, then I have two groups or more. How many groups? If it is two groups, I'll go here. If I go here, parametric or not parametric, parametric student t-test, non-parametric man-Whitney test. Okay, and remember, if it is non-parametric, I'll transform it to make it parametric and go back here. More than three groups, ANOVA or Cruz of Wallace, and if it is not parametric, I'll transform it to be numeric again. Sorry. Okay, please till they all join, can you ask any question? Do you have any questions?
What did we mean about intervals when we said the dependent variables?
Yeah, it is the same as continuous. Because I collected those algorithms from different books, from different websites, so they have different names, but for the same thing. So I hope that slide we skipped was clear to everybody, because yeah, they are all discussing the same way. So the most difficult thing in statistical analysis is to choose the best test, and choosing the best test is according to any of those algorithms, and it's actually easy. When it goes further into details, for example, when we are going to those non-parametric analysis and where we can apply each one of them, that will be difficult. But for medical research, it's truly unlikely to do them. For example, in all the studies we all read, we will find those correlation regression, and those are rare. Most likely chi-square, t-test, Fisher exact test, which is a part of chi-square, as I told you. The smallest 2 by 2 table will be a Fisher exact test, but for others, chi-square, ANOVA, which is just for 3 groups or more, and that's it. Okay, like 90% are resolved already. So if we move on, we will take all the questions maybe in the third call or at the end of this call, but now we can start with the second part, which is data collection. Okay. Actually, the most important problem in data collection is the results we will have. Okay, it's either like ordered in a very good way. We have it classified. Each column will give me just one information, or I'm just lost between the huge amount of data. And remember that it's not just like that research that will give me 10 columns or 15 columns. Actually, most of the projects you will do will be like 20 columns just for characteristics of patients, and you will have like 100 columns. And this is actually huge data to analyze, to find out that, oh, I did a mistake in planning for that project, and now I'm paying the price for that. So it's better to plan, and in planning we are saving a lot. And yeah, take it from experience, and for guaranteed, it's a lot of times. So to do research, it's a very long journey, but we can divide it into those 12 steps, okay? And we will discuss them. But I want to tell you that we start from studying the introduction or all the textbook in that field, proposing a research project, reading, summarizing. Then I collected the data, did the analysis and everything. And when I go to publishing, okay, it doesn't just I publish a paper and that's it. I usually go back to studying, because if we don't publish continuously, it's better not to publish at all. Okay, there's a very known quote that say publish or perish. So if you start to publish, you need to increase the amount of publications you have every year. But if you just publish 1 or 2 papers and you are waiting for the citations, that's nothing, and you will lose your not your job in our countries, but most likely your position in clinical research in that field. So I don't know where to put this. Maybe here in the middle is the best. Okay. Studying, what do we mean by studying? Actually, by studying, I don't mean that I need to be so professional and understand everything like an expert in that field, but I need to understand the very basic knowledge in that field, because I'm going to contribute to science in that field, okay? So to do that effectively, I need to understand what they are doing, what is the actual status, what is the process right now, because if I'm not affecting anything in that process, I'm doing a nonsense research, okay? The research should start from the problem, not from my just illusion. When studying, I don't mean like studying and reading the books waiting for the exams. I mean, like asking questions while I'm studying. Why is that like this? How is that happening? What for a reason? What is the conclusion out of all of this? All these questions will give me the importance of each step of the guideline. For example, it will give me the importance of the percentages they put in their lectures. Why does the side effects happen? And how do we estimate the importance of a drug? For example, while some drugs have a lot of side effects, we still give them. So why? Okay, we need to understand all of these stuff before we go on to the next step. And of course, you understand that we will have a lot of bad comments, discouraging attitudes from colleagues and from experts, and they will tell us that you can do any research in that field, but sometimes, yes, actually students can do better research than their seniors. Of course, we will need a lot of guidance, we will need a lot of support, but we have that innovation, that imagination that makes us like generate more ideas, because as you all know that as the person grows older, he will lose that ability to ask questions or to ask better questions, to do better imagination. Okay, now it is right in the bad place. The second step, okay, I studied, what should I do right now? Actually proposing, and what I'm proposing with, I'm proposing a BICO. Okay, I studied everything in that field, and I feel that there is a very good and important question, and the question is defined by a BICO. Okay, so I need to think about rheumatoid arthritis patients. Okay, this is the P of the BICO. I need to understand if there is an intervention is better than other intervention. This is the intervention and the comparison, and in which outcome. Okay, so I need to assess, for example, a side effect. Which drug will cause more side effects or will give a better quality of life? Okay, and this question is actually usual, and I believe it will be like when I search for it, I'll find the answer. So I need to generate more because just one of them will have that possibility of going on to be a research project. Okay, how? For each time I generate a research question, I need to go to make a null hypothesis and an alternative hypothesis. Okay, we need that BICO that is really special, that worth the effort I'm putting in it. So the null hypothesis is my BICO is already answered. Okay, actually nowadays most of the BICOs are already answered, so we do not expect to find the BICO or to find the research project right away. Okay, we need to think about a very rare disease, for example. Sometimes we need to think in a different way. Sometimes we need to assess a new drug, for example. Sometimes we need to assess a new outcome. Okay, so for example, I'm doing that research on, for example, quality of life of patients in a very poor situation, like in Syria, for example, for cancer, for example. Okay, so I know that this is not studied. Okay, and this is actually our opportunity, because we know that in Syria there are a lot of questions about a lot of interventions. So we can study that, but actually if it comes to Qatar, to Germany, it will be harder to find a BICO that is not already taken. So how should I know if my PICO does go to the null hypothesis or to the alternative hypothesis. Okay, to do that, I need to do my search. Okay, and where do I do that search? Usually we go to the medical literature databases and I ask them, do you have an answer for my question? Okay, most of the times they have the answer, and when I have the answer, okay, I learned something new. But if there is no answer, okay, and I think it is still a very important question. For example, I might get answers to another questions. So when I get these answers, I do not expect the answer to my question to be that important. So it doesn't worth trying to solve it. So we need to search and we need to read what we are searching. Actually, I put here a link for a very good PubMed tutorial because searching is not that easy. Okay, we said we need to search. Okay, we said we need to search for the papers in different databases. And what are the most important databases? Cochrane Library, actually this is a library for just systematic reviews. Recently they put a new website, Cochrane Central, that you can search for a randomized control trial, but it's really high in evidence, but it doesn't include everything. So PubMed is the first choice, Embase is the second choice, and this is according to their coverage of medical journals, and we still have those journals that are not indexed, not in PubMed, not in Embase. So sometimes we have a very good article that doesn't appear on the first page of PubMed, and sometimes people say that in Google Scholar I can find a better result, and yeah, this is actually feasible or applicable sometimes, but for usual use we need to be experienced in PubMed. Reading. Okay, I collected the papers, and now what should I do? First of all, to save our work, we need to import them. I did the search, and the search is not that easy actually. I need to spend 1 or 2 days to search for that topic in my specific terms. And after I get my collection of papers, I should import them to put them in my library. And the library, the virtual library for journal articles is usually Medline, Mendeley, or EndNote, those reference managers. So when I use them, I save my work. Okay, so please just keep using them, and this is another tutorial for using a reference manager. Okay, after that, I need to summarize. Actually, if I read everything, I can't get to any conclusion if I don't summarize them. And what should I summarize out of these papers? First of them, the objectives. If their objectives answer my question, then my question shouldn't be a question anymore, okay? It's an information now. Their study design. And why? Because their study design will define my study design when I'm planning for my research study. And their outcomes, okay? How they are measuring their outcomes, okay? And many other more important factors. So when I collect all these information, I will be able to plan for my own project. Okay, and for planning, good planning is a very detailed protocol. And how should that protocol be? Actually, there are different checklists that I should follow. For example, for an RCT, which I should follow a very long, like it's a 10-page a questionnaire that I should fill in to make a very good protocol. And these protocols, what are they made for? First of all, I need the protocol to get the IRB approval. IRB means the Institutional Review Board. So this board is actually made to confirm that this study is a good study. Okay, they will revise it scientifically. They will go to the literature and confirm that your study is not answered somewhere else. They will check it clinically. They will go to an expert in that field and they will ask him, if we have an answer for this question, will that be beneficial for from a clinician point of view, and so on. And for some interventional studies, and actually not some interventional studies, most of the interventional studies need to be put in a clinical trial registrar before I start recruiting my patients, because we are intervening on humans, and when I do that, for example, in Syria, nobody else should try the same drug on different population at the same time, because I might get very bad side effects. Okay, so it needs to be registered, and if they are going to do, they will split. For example, the sample size, we will have some in Syria and some in Brazil or anywhere else. So this is actually a very good way to collaborating between researchers. For protocol, what is the first part of a protocol? It's actually the introduction. And what does the introduction consist of? First, the background. The background means, well, what is the general knowledge about that? Then the rationale. What is the logic for my research project? And what is the aim? Actually, the last sentence of my protocol introduction should be the aim. I'm planning to do blah and blah, and I'm planning to report a case of rheumatoid arthritis that has something and something special, for example. And where do I get this introduction from? I get from the summary I get from the papers I searched for. So all these steps will just go here to put this introduction. Then the objectives, okay? The objectives are the goals for my research project. So I need to classify them into primary outcomes and secondary outcomes. What are the primary outcomes? They are actually just 1, 2, or 3 maximum. We do not have more primary outcomes because I need to focus on them. When I'm calculating my sample size, I focus on them because I need them to be important. But if a secondary outcome can't be important in my sample size and it requires a lot more participants, then I can skip that. Okay, I can have as many secondary outcomes as I want, but it's usually important to keep them focused. Okay, because when they are focused, I can collect more data, more accurate data about these variables, and I can collect I can decide on the variables that can answer my questions the best. But when I have a lot of outcomes, everything gets confused. What is the study design, and how should I decide on a study design? Actually, I will give you some scenarios, and I hope you help me find a better, the best research design for them. Okay, if I tell you that I want to study something about diabetes, and I went to that outcome, and I searched PubMed, and I found a lot of RCTs. Okay, I found, for example, 10 RCTs, and I tried to understand the answer to my question, but I found that that intervention is beneficial in some studies and is not so beneficial in other studies. What do you think the best study design I should do?
Systematic review.
Exactly. Because I have several RCTs and they are contradicting. Okay, if I have 2 RCTs, 2 really good RCTs, and they give me a direct answer to my question, then should I do a systematic review? Do you think I should do?
Literature review.
Yeah, literature review is similar to making a summary of, okay, if I want to publish and I really want to publish, I can make a literature review, but it adds nothing really important to the literature, unless like I'm a real expert in that field. But I'm talking from the perspective of yeah, I'm talking from the perspective of a normal student or like an intern. Okay, so I don't believe that we need to do literature reviews. Okay, and even if we do literature reviews, our opinions are not so important unless we are supervised by a very important researcher in that field. Okay, the second possible scenario can be, I searched and I found 2 case control studies, okay, and I found nothing else. 2 case control studies and 2 case series studies, okay. This disease is actually rare, and I found those. What do you think the best study design I should do? If you do not have any answer yet, I will say that I should ask that question. Why there is no more studies? Why we do not have any cohort studies, any bigger studies? Okay, and the answer is actually already told. So if I don't have any bigger studies, I need to understand that it could be the disease that is the problem, okay? If it is rare, then there shouldn't be cohort studies, okay? I cannot do cohort studies in another sentence. So I will need to do another case control study. If I'm doing a research on that, if I'm doing an interventional study, I will take a sample of those patients and I will do the intervention and I will assess them before and after my intervention, okay? If I believe that I have a good sample of patients. Okay, another scenario can be, yeah, please.
Ibrahim, how are you? So
Alhamdulillah.
I just want to ask you, you said that if we have like 2 RCTs with similar results, what is the best study design? So it will be systematic review also, right? Or what?
Yeah. Actually, the first example was the RCTs are contradicting, okay? And they do not give me any good conclusion. So an RCT will solve that and it will combine the data, it will summarize them and will give me one answer after assessing everything. But if I have 2 big RCTs that are saying my drug is beneficial, does it worth the time to do a systematic review?
So can we like depend on them for the guidelines? It's enough to depend on them, or we need other RCTs to prove? I don't know actually.
Yeah. Actually, guidelines will depend on the best available evidence. Okay, if I don't have any paper but one case control study, a guideline can depend on that. Okay, so it's not a big problem.
And because these systematic reviews have the similar results, so I don't have to do further analysis for these results.
Exactly.
Right?
Exactly.
Oh, okay.
Ibrahim, is there any specific number to study to be able to do a systematic? For example, I need more than 5 studies published or 4. Is there any specific numbers, or it depends on the results?
No, actually, there is no specific number, and it can be a 0. If you imagine that we can do a systematic review on 0 studies, and how is that possible? I plan for a systematic review in my mind, and I feel that there are several studies that are applicable for my systematic review. But according to my criteria, if you remember, a systematic review does have a lot of question, scope bias assessment, a lot of things to go on. With. So I went to these published articles, and according to my criteria, I end up with no good study to conclude, to tell the people about. So my conclusion, we do not have any good studies in that field, and we need more studies. This can be a very good systematic review.
Okay.
Okay. And on the other side, you can find that systematic review with 3,000 included studies. Okay, so all possibilities are there. Okay, another example can be like I searched for an exposure, and I want to see if that exposure, for example, if smoking cause a cancer in some place. Okay, and I didn't find a cohort study. Okay, I just found some case control studies. Okay, but in my population there is quite a high smoking prevalence, and I'm seeing a lot of patients with this cancer, and I have the funds to do that study, what that study should be.
Cohort, obviously.
Cohort.
So yeah, exactly. So this is how I decide on the study I should do. Okay, and if I have, I think any other scenario should be discussed, but we do not actually be the only one. We aren't actually the only one to decide. We can ask an expert in the field. There might be studies that I'm not aware of. Okay, and we can discuss that with more people. So, well, what comes after that? The inclusion-exclusion criteria. And how do I decide on that? After collecting everything, I will have those 4 or 5, whatever studies that are working on my population, on the same population I'm targeting. Okay, I see their inclusion, their exclusion criteria, I read their limitations, I will benefit from their experience, okay, because I don't want to make the same mistakes they did in the past. So I benefit from that, and I need to watch the balance between internal validity and external validity. So what is internal validity? Okay, I need to be really strict in choosing my controls. I really need to be really specific. I need to give my patients the best possible care, just to control for every other factor, but for my intervention. Okay, do you agree? That will give me the best internal validity. That will give me the best results for my studies. But actually, if I do that and I put everybody, I give a pill in an ICU, okay, and I get that very good outcome. Can that be generalizable? By generalizable, I mean if I give my paper to the doctor beside my room and tell him that you can use this pill can treat that disease, can you apply it? And he applies it to his population of patients, and it doesn't work. Okay, so what is the reason? The reason because I controlled a lot. Okay, I control. I did more than the usual care. So I really put much effort in internal validity, but I lost external validity. So I need to be balanced between those, okay? And I don't need to want to do it randomly. Everybody comes with no exclusion criteria will be recruited for my study. That will be highly generalizable, okay? Because I'm recruiting everybody. I'm recruiting every patient that presents to my hospital. But although this is generalizable, but the internal validity is not very high. Why? Because the population are really heterogeneous. Okay, some of them have comorbidities, some of them smoke, some of them have mental disorders, and all of these things will affect my study. Okay, so I need to be balanced between those. I can't maximize them both at the same time. Okay, then what are the tools of measurement? How can I measure the outcomes I want? Okay, now I know that quality of life is an important thing for my intervention. Mortality is another important thing. The count of white blood cells is the third important thing. Okay, so how should I do that? Okay, for white blood cells, I can control. I will use the same laboratory, and I will use the same units for my numbers, and this is really actually easy. But for quality of life, is it that easy? Okay, actually it's not. I need to remember that for quality of life, there are tens and hundreds of questionnaires that are available. So how to pick the best? Remember that we collected, yeah, please, Maya.
Same as the concentration levels and those things. Yeah. I can depend on previous studies, the most reliable ones. I can apply the same tool.
Exactly. I will use the same tool, and I will maybe I will approach them. I will ask them, did you find this tool really appropriate for our patients? They will tell me, no, actually, we have that problem. Okay, sometimes, which is better, they report that in their limitations, but sometimes they do not. Okay, and it doesn't bother me or them to contact them and tell them, can you recommend a better quality of life questionnaire for our patients? And they will be happy to feel like an expert in that. Okay.
So just a question for these tools, if we want to do some modification to make them valid for my population, okay, so I need to contact the researcher to take some, or what? Or if it's like published, it's for everyone.
Yeah, you can put them in your references, okay, but if you want, for example, sometimes it's not available online already. So for these specific times, you will have to contact them. But if it is available, they sometimes put a sentence that say that you need to contact us. Okay, for example, for that questionnaire for facial expressions of happiness. Okay, you will remember that visual facial scale for Al-Deen. Actually, they have a license, but it is quite easy to get their permission. So they have a form. You put that I'm going to do a study on those and those, and I will not use that questionnaire for commercial purposes, and they will give you the questionnaire that is translated to your language. Okay, so it depends on the tool.
Good. Well, thank you.
You're welcome. Okay.
Yes, and can I add something?
Of course.
What about the pilot studies? Like if I want to design a questionnaire and I can validate it by a pilot study or a process of validation, I think I can have a small process of analysis on the data that I have collected by this pilot study. Is it the right way at that point of time when I'm doing the protocol?
Yeah, yes, of course. This is what you should do. Actually, it's not a good way. It's I mean, yeah, you should do that. It's a must. It's not a good way, because if your questionnaire is not valid, we will come to that in the next slides. Okay. I defined the tools I want to use, but that's not actually everything. Okay, I need to put instructions for them. Why?
Excuse me, Ibrahim.
Yeah.
Sorry, but we have like 1 minute and the call will end.
So yeah, so maybe we can continue. I'm really sorry, but we will need like 15 minutes at least for another call. So I hope that is fine. And yeah, we will call you in 10 minutes. Okay. Yeah. Thank you for your patience. Goodbye. Bye. Okay, so welcome to the third part. As we said in the last call, we have those tools, okay, and I have them, and I developed them, and I prepared everything. But when I give them to data collaborators, they do not have the same understanding of these tools as I have. Okay, so I should put detailed instructions for each question This question should be asked to the patient in that way, and I should have those meetings with data collaborators in order to get the best quality of data. Okay, now assessments for, not assessments, actually tips to get those best tools. Okay, the best tools do not collect every data possible. Okay, we need to collect as much as we need. Okay, we shouldn't collect more because this is time consuming. This will cost time while we are collecting data, while we are doing data entry, and while analyzing, and that can confuse us with the with more outcomes. Okay, so just collect the data suitable. Closed and open questions. I remember that I had to do the analysis for a study where the doctor collected every data possible, and he collected them like in a narrative way. He put a lot of comments, and you can see that each cell is like that huge. And for example, for CT, he put the whole report of CT, and actually he consumed a lot of time typing everything down. But this is not how research is. For example, you can divide that, the CT, into 3 or 4 outcomes and just put ones and zeros if this is available or not. And this is the smarter way and the better way for data analysis, because everything he wrote, we needed to delete it and regather data from scratch. Validation is really important, especially for those printed questionnaires. So when I give the printed questionnaire to a patient or a participant and I ask him to fill in, that questionnaire should be validated, because what is validation? Validation means that a study should be conducted on that questionnaire to make sure that this questionnaire is collecting the data that is made for. Okay, so this questionnaire is valid means this questionnaire is very good to collect data about that outcome. Okay, if we do not have any valid questionnaire that is validated already, we should validate our own questionnaire. We develop the questionnaire, and this is a lot of steps, around 10 steps. And after that, we have that validation of our questionnaire. When we publish, when we submit a paper for publishing, and they will ask us, and if our questionnaire is not validated already, they will lose interest in our papers. And we should know that if a questionnaire is valid and we just change some questions, it loses its validation. If we translate it from language to a language, it loses its validation. So we need to validate it again. Okay. Now, what is the best way to get data? The best way is actually to collect the data via an interview, but this is truly time consuming. So yeah, we can collect data via interviews or telephone calls, and we will have that high response rate, low non-response bias, but we should consider the benefit of that with and balance it to the time it will consume. What are the benefits of papers, those questionnaires that are distributed on paper? Actually, it's better in low resources country, because we do not have funds for those electronic data collection tools. And for specific groups, for example, for those elderly, I cannot just give a tab to my grandma and tell her to fill in a questionnaire on that tablet. And of course, when we do an interview, it's better to interact with the person in front of us, not to be working on a tablet or something like this. However, nowadays, like this specific cause is really not so important, because people are getting used to doctors who are using their computers in front of them. Yeah, actually, in the past, the best way was paper data collection, and it still has some benefit. For example, when I need to specify my sample, if I want to go to that exact lecture and give the questionnaire to them, I better go there and give them papers, because if I send them an email with the link, yeah, most likely they will not share that link with somebody else. But if they share the link with somebody else and I'm collecting data anonymously, and I get, for example, two more participants, I will not know who those two participants are. Okay, so yeah, that will confuse me. And for example, if they do not share the link with somebody else, but somebody had some kind of technical mistake, and he thought that his questionnaire is not valid, so he repeated it. So for this, I cannot make sure, and for example, he just changed his answer for one of my variables, so I will not know, and I will have twice of that questionnaire, and I can't exclude it, okay, because I don't know it, I don't know that person. That person will not come to me and tell me, oh, I filled the questionnaire twice, okay. So we have problems, and these problems can be solved by paper data. But what about electronic data collection? Actually, it saves a lot of time, because when we think about data that are collected on papers, we need to re-enter everything on these papers into Excel sheets or into an Access form, whatever it is. We will discuss data entry in next session. But when we are using data collection on an electronic tool, it will be directly transferred to that data sheet. We can use another thing in electronic forms. For example, skip patterns. If I ask you if you have asthma and you say no, we will end the questionnaire. Okay, you don't have to answer everything that is following, and this is actually applicable to paper questionnaires, but it will be difficult for participants understanding. But here in electronic data forms, it will be electronic, automatic, so we can make use of that. Okay, after I prepared everything, prepared the tools, I prepared my protocol with the tools, with everything, with the instructions, with my team, I should go and take that protocol to a consultant, okay? What should that consultant or expert do, okay? We shouldn't actually go to just one expert. We should go to many of them. The first one should estimate the clinical importance of my question, okay? Remember that till now, I didn't do anything. I'm just planning, okay? So if I go to him and he tells me that clinical importance is not that high, and you need to add a variable or an outcome to your primary outcomes, and this outcome is blah, blah. So now I need to revise my protocol and add this outcome for scientific feasibility. So if I do this research, okay, my research project doesn't answer the question, okay, and sometimes we follow that trap. Why? Because we are following other papers, okay. But these papers just make us deviate from our original PICO. So in the introduction, I have the PICO I'm planning to solve, but for my methodology, that doesn't match, okay? For ethical acceptance, I go to a consultant and he tells me, yeah, your paper, your protocol is really good, but when you will apply to the institutional review board approval, they will refuse it because it's not that ethical to give that drug for that reason. Okay, so we should revise that and minimize the ethical issues in my protocol. Sometimes we need to stop the whole study because of non-valid ethical approval. Okay, methodology coherence. Okay, my methodology doesn't match with each other. Okay, so I have the methodology and the outcomes, but the outcomes are better collected in a different study design. Okay, so I can change the design. It's actually not so accurate that if I have those scenarios, I will have to do the study design. No, actually, it can be changed. For example, when I'm doing a prospective cohort, it can be changed to a retrospective cohort. When I'm using controls that are currently in a hospital, I can use controls that are historical, that were in the past in my hospital. So we can change a lot in the methodology. And statistical, I need that approval from a statistician. I go and ask him, is my sample size correct? Okay. Will my data be analyzed in a good way, or should I change my scales? Should I do something else? Do you think that my questionnaire will not be good for your statistical approach? Okay, and so on. Now for collecting. Now I revised my manuscript and I go to the next step. Remember that those are the steps, the 12 steps we talked about in the last call. So is it good to go like in this picture? We go and collect all the data by a single hit? No, actually it's not that good, because when I'm like a little bit confused about the data I will have, it's better to take 1, 2, 3 questionnaires, let's say 10, and analyze them. I should take them to somebody and tell him, do they make sense to you as they make sense to me? Okay, I should take them to a statistician and ask him, can you analyze this kind of data? Yeah, he approved my protocol, but after he sees the data, it will be a different opinion. Okay, so we need to manage that. We better use the most efficient way after that. Okay, most efficient, it means like I go to the place where I can find most of my participants and I collect a high number of my sample size in a single day. Okay, but that shouldn't be in the very first day. That should be delayed, because when I collect data and I found a mistake, correcting the mistake will be corrected for just 10 participants, not for 100 participants. We don't always have to collect our own data. Okay, for example, I talked to somebody else who is doing a research in that field, and I'm just thinking about an additional outcome. So I can add my outcome or my questionnaire to his assessments, and I will get my data as secondary data from his data collection. So this is really easy. And I remember that for one study, we went to the hospital and we found that the medical records of their patients are collected like in the usual way, but for neural injuries, they collected some data in a different way. Okay, they have the medical records, the usual medical records, but they also had one paper that has the most important outcomes out of that medical file. So we checked these papers and we actually found that most of our outcomes can be solved by these papers, and we just had to go to the actual medical records for maybe 3 or 5 patients. So this is actually a very time-efficient way. After I collect some data, I should go and make a meeting between the principal investigator and the data collectors, and they should discuss how they are collecting data and how that will go on, okay? Because sometimes he has another expectation from data collection, and they are collecting in a different way. Okay, we said that they should meet and talk about the questionnaire and go through the questionnaire question by question, but after that, and after 2, 3, 5 patients, the principal investigator should go to them and meet with them again, and probably a statistician should come also, and they should discuss in more depth. Why? Because those data collaborators will have the problems they already faced. They will report to us the difficulties they are having for specific outcomes, the questions the patients are not understanding, okay, and so on. And there might be a lot of fights. After data collection, should data collaborators just go away and they should say that, yeah, our work is done? Not really. Actually, data collaborators should stay till the end of data analysis. But why? Because between data collection and data analysis, we have data cleaning. Okay, data cleaning means all those comments, all those notes, additional notes should be added in a specific column. We can, for example, report a paper and add a table saying that, and we have some comments from our data collaborators. These comments are, this person has a comorbidity of blah blah, but we do not have a column for comorbidities. No, actually, we should assess that from the very beginning. If we have that comorbidity important, we should add a column, and everybody else from data collaborators should collect that data. Okay, if somebody just one collect, for example, the pathology report, and others do not, other data collaborators, then that person is making a lot of effort on something that is not going to be analyzed. Okay, and that's why they should just stay with the data analysis and suggest some. Actually, they know about the data more than the data scientist, more than the principal investigator, so they can suggest more analysis, and they can put more comments on data analysis. So when we know that there might be a problem, we should anticipate and watch out, because that problem will make a very big problem in the future if it is not solved at its time. After data collection, we will have data cleaning, and we will talk about this maybe next or in 2 sessions. After that, analysis will stay with us till the end of this workshop, and after that, writing and publishing. And after publishing, we go back to studying and taking another research project. So I think this is my last slide, and all your questions are welcome. I'm really sorry for the long presentation today. Do we have questions? then you are so welcome. If there is any question, I will stay here for like 5 minutes. And thank you so much for your attendance and for your patience. Okay, I can summarize the statistical tests, and this is actually a very difficult word for me. Okay, first of all, we need to ask that question. What are the types of data? Categorical, okay. I have one variable that is categorical. And what is the other thing that I'm like combining to that categorical data? If it is categorical, then I have two categorical variables. Okay, for two categorical variables, what are my options? Actually, two. The first one is having 2 by 2 table, or having 2 by 3 by 4 by whatever, or 3 by 3, whatever it is. Okay, so if it is 2 by 2, Fisher exact test. Okay, if it is more, chi-square test. And this is for categorical and categorical data. Okay, sometimes we do not have the other group, so we just have one group, one sample, and we will use the proportion of the normal population. Okay, now for categorical and numerical data. Okay, we have two variables, one categorical and one numerical. So for categorical data, I will use it to classify my groups. Okay, so I will have two groups for now, and continuous data. So I have a mean and a standard deviation for this group, and mean and standard deviation for this group. Okay, what is the test I should do? I should ask one more question. Are they parametric data or normal distributions? Okay, if it is yes, normal distributions, I should use t-test. Okay, if it is not a normal distribution, I should use Mann-Whitney test. Okay, if it is just one group, I will assess it in accordance to the mean and standard deviation of my population. It will be a one sample t-test. Okay, and if it is two groups, also Mann-Whitney, but with the mean and standard deviation of the normal distribution of the normal population. I'm saying the normal population, but it's actually not accurate saying, because it can be the comparison I have, but the comparison I already have them from historical data, from other paper. I can compare my new data to another paper, to the mean and standard deviation of another paper. Okay, that is actually okay. Okay, if I have more than two options for the categorical outcome or variable, so I have a 3 or 4. Okay, let's say 3, and I have the other variable is continuous, so I have mean standard deviation and mean and standard deviation for the others. Now what do I have to do? ANOVA test. Okay, but this is if they are parametric. Okay, if they have normal distributions. Okay, if they do not have normal distributions, what should I use? Kruskal test, that difficult name. Okay, so now we ended with categorical and numerical data or interval data. Now we are just left with interval and interval. Okay, if they are both continuous, we will have that continuous and that continuous outcome on two scales. What should I do? Correlation or regression? Prism or I actually forget the name of the other test, but those two tests for correlation and regression. Okay, it depends if one is dependent on the other or they are both independent of each other, but they correlate. Okay, are you satisfied? Thank you, Basel, for your question, and thank you all for your attendance. See you in 2 days after the weekend.